the next numeration system that we're going to discuss is one called the Hindu-Arabic numeration system. So I'm wondering if you're familiar with this system. And the answer, of course, should be yes. So if you are not aware, the Hindu-Arabic numeration system is the one currently in use in the United States and in most places around the world. So there was actually a recent poll that was posed to over 3,000 respondents asking if Arabic numerals should be part of the curriculum in schools, and only 29% of people answered yes. I think that's clear that a lot of people are not aware that our number system is called Arabic numerals or the Hindu-Arabic numeration system. So this one may sound a little strange, but just because you probably haven't heard that name, this should be the number system you are most familiar with. So the Hindu-Arabic numeration system, it is an example of a place value system. And a place value system just means that the value of your symbol depends on its position or where it's placed in your number. A place value system requires a base. In our case, it's base 10. And it also requires, of course, a set of symbols, including a symbol for 0. So technically speaking, if a system doesn't have a symbol for 0, we can't officially call it a place value system. So ours is a base 10 system because each place value represents a power of 10. The Hindus in India are credited with the invention of 0 and the other symbols that are used in our system. The Arabs who traded regularly with the Hindus also adopted the system and brought it to Europe, thus the name Hindu-Arabic. So the symbols 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 are called digits. From the Latin word for fingers. So in our Hindu-Arabic system that we are already familiar with and that is currently taught in American schools, there are a total of 10 symbols. And if you think about that, that's all we need, right? We don't ever have to use any symbols other than these. We just use combinations of those symbols, right? So in our Hindu-Arabic system, if we start with the number that is rightmost, we call that the ones place, right? And so if we had, for example, like in this case, we have a 7 in the ones place, that just means that we have the number 1 7 times, right? And then we would go on to the tens place. So the number to the left of that is the tens place. So that's how many tens we have. So like, for example, the number 37 means that we have 3 tens and 7 ones. And then from there we keep going. So after that is the hundreds place. So eventually you'll do decimals and you'll talk about things like the hundredths place. So just be careful that you understand that that's not the same thing, right? So hundreds and hundredths are different. Hundredths or thousandths, those numbers are after a decimal point, which you won't do until you do decimals, right? So make sure that you know how to say this correctly and also spell these correctly. So we keep going up by powers of 10. So like if we took the number 1 in the ones place, if we took the number 1 and multiplied by 10, we'd get 10. If we take 10 and multiply by 10, we get 100. If we take 100 and we multiply by 10, we get 1,000. If we take 1,000, multiply by 10, we get 10,000, and so on. So that's why we call this a base 10 system. So after thousands, or I guess before thousands, if we're moving if we're moving right to left, then we're kind of going opposite of the usual direction. So to the left of the hundreds place is the thousands place, then 10,000s. This is typically hyphenated, although I have also seen it not hyphenated. So I prefer that you hyphenate it, but it would not be incorrect if you did not hyphenate in this case. So again, 100,000s, that is typically hyphenated, but I have seen it not. So it's okay if you don't. And then you need to know these, right? So you need to know after, or I guess to the left of 100,000s is millions, then 10 millions, 100 millions, then billions, then 10 billions, then 100 billions. And you'll keep seeing that pattern. So this actually keeps going forever, and there's more and more names for these. How far should you know? I suppose that's a matter of opinion. In a world where our national deficit is typically in trillions of dollars, I would recommend you at least know out to trillions. And that's next, right? So after 100 billions or to the left of that, next would be trillions, 10 trillions, 100 trillions. That's probably good enough for now, but technically it keeps going. So before that, to the left of 100 trillions would be quadrillions, 10 quadrillions, 100 quadrillions. There's quintillions, sextillions, septillions, octillions, and it just keeps going. And you can actually look those up if you're interested, but I think you're safe if you know at least through trillions would be good. All right, so we're going to practice writing some of our numbers in what's called expanded form. And there are different versions of expanded form that you might see or that you might teach students. And it just depends on the level of, like the grade level that you're teaching. So this number, 3,407, the first way that we would teach, so this is like at a first grade level, the first way that we would teach that in expanded form would just be to break up these numbers based on their place value. So for example, that 3 being in the thousands place means that it represents 3,000, right? The 4, since it's in the hundreds place, represents 400. The 0, you would still just write that as 0, or if you didn't write it, that's okay. I kind of prefer to write it, but if you don't, I'm okay with that. And then the 7, since it's in the ones place, is just simply representing 7. And so then we would put addition in between each one of these. So if you are teaching expanded form at a first grade level, this is likely what you're going to ask students to do. Now, once we get a little bit beyond that, second or third grade, where students understand the concept of multiplication, we would start writing this a little bit differently. We would say, well, actually, 3 being in the thousands place means 1,000 3 times. So that's really multiplication of 3 times 1,000. And then 4 being in the hundreds place means we have the number 100 4 times. So that's 4 times 100. But you can see why we wouldn't do it this way for like first grade. If they haven't covered multiplication yet, we wouldn't write it this way. If you did include 0, and again, you can skip it entirely, or you could just write 0. But if you wanted to like show everything here, you could write this as 0 times 10, right? Because it means the number 10, 0 times. And then I'm okay if you just write plus 7, although if you really wanted to expand on this idea and make sure students are understanding, then you could say this is really the number 1 7 times. So it's really 7 times 1. So that would be like our third grade type of expanded form, what we would expect those students to do. And then we're going to do one more, and this is the one I want to see because I know that you all know this. So if I ask you for expanded form, what I really want is I want expanded form with exponents. And again, you just wouldn't do this like with third grade because we haven't covered exponents yet, right? Or at least not until we've covered exponents. So really we could say, okay, actually, for example, the number 100 is actually the same thing as 10 to the second power, right? Once we understand what exponents are, right? The number 1,000, that's actually 10 times 10 times 10. That's actually 10 to the third power. And this really emphasizes the fact that we have a base 10 system. Like by the time we get to 10,000s, that's really 10 to the fourth. And 100,000s is 10 to the fifth. And this just keeps going up as we keep moving to the left, and it goes down as we keep moving to the right. So the tens place is really 10 to the first power. The ones place is actually 10 to the 0 power, because anything to the 0 power is just 1. And we won't get to decimals yet, but when you do get to decimals, they just keep going down. So then you have negative exponents, right? So once we understand the concept of exponents, we would write it that way instead, just to emphasize the fact that these are all powers of 10. This is a base 10 system. So we would write this as 3 times 10 to the third plus 4 times 10 squared plus, again, I'm okay if you skip it entirely or if you just write 0. But if you wanted to emphasize this, you would write it as 0 times 10 to the first And again, you can just write this as 7 or 7 times 1, but if you really wanted to emphasize this idea, we could write that as 7 times 10 to the 0. So this is what I want, right? When I ask you all for expanded form, I want to see that expanded form with exponents. All right, and then we also want to practice writing our numbers in words. And be really careful. I don't know why this confusion exists, but inevitably every semester I'll have problems where I ask students to write an expanded form and they'll write it in words. I don't know why those get confused, but like make sure you know which one I'm asking for. So if I'm asking for expanded form, I'm wanting like this addition, multiplication, exponent thing, right? If I want it in words, I'll say in words, right? So let's just start on the left and we'll move our way from there. So that 2 is in the millions place. So that's the number 2 million. And that's how I would say it, and that's how I would write it. You definitely want to be spelling correctly here. And you don't have to, but it kind of helps me keep track of where things are in my number if I put my commas in the same place, right? So 2 million, and then I've got a comma. And then that 4 is in the hundred thousands place. So that's 400,000, but then there's also the 7 would represent 70,000, and then the 3 would represent 3,000. So the way I would write this is 473,000. The word and does not belong anywhere in here. We would only use the word and for a decimal. So until we get to decimals, I don't want to see the word and. And I tend to make that same mistake too. I'll say it as 473. You should not technically say it that way. It's 473. And one way to do this is just kind of let the comma break up the numbers and then just put whatever place value. So like here we have 473, and then since the 3 is in the thousands place, I wrote thousand, right? So then this next part is the number 906, right? But since the 6 is in the ones place, I don't need to write anything after that. So I would just say 906. I'm going to put my comma in there. But again, it's not 906, right? It's just 906. And then I am missing one thing here, and what I'm missing is a hyphen. And where that hyphen needs to go, so these are flexible. I talked about these hyphens. Those are flexible. I'm okay whether you put those or not, but you absolutely do need to put a hyphen in anything like this 73. There needs to be a hyphen between those. So basically any 2-digit number other than the numbers 10 through 19 don't need hyphens. And then the numbers that end in 0, like 20, 30, 40, 50, 60, 70, 80, 90, those don't need hyphens. But anything else does. So 91, 55, 24, 38, all of those numbers need a hyphen. So we would say this and write this as 2,473,906. So one more example. We have this number 36,384,069,010,486, and we want to write this using the digits 0 through 9. So 36 trillion, I could just write 36 and then put a comma. 384 billion, so that would be 384. And I'm just going to make sure that this ends up landing in the billions place. Then we have 69 million. So that would be 069. And then we have 10,000. So that would be 010. And then finally 486. So again, we have the 10 for our thousands, the 69 for our millions, the 84 for our billions, and the 36 for our trillions. So that would be our number in digits. And if you're wondering where in the world did I get such a big number, Actually, at the time that I recorded this, or at the time that I created this, I got the notes made from, this is the US National Debt Clock, so usdebtclock.org. So you can see it's already gone up from that. But at the time that I looked it up, that was the current US national debt. And this is January 2025 that this video is being made.